Today we're going to do a Lewis structure and 3D model for ammonia, NH3. So when we're working with ammonia, the first thing we need to do is to do a Lewis structure. So I have 1 nitrogen, I have 3 hydrogen. So my nitrogen has 5 valence electrons. If you don't know how to find a valence electron, you need to get out your periodic table, count over. If you count 1, 2, skip the D block, the D orbitals, 1, 2, 3, 4, 5, you're going to notice that nitrogen is right there, and it has the 2 S's and 3 P's, so it has 5 valence electrons. So I have 1 nitrogen, and so that's 5 valence electrons. Hydrogen, right up there in the corner, it is 1s1. And so I have 3 of them. It has 1 valence electron. 3 and 5 is 8. That's pretty easy. Okay? So to do a Lewis structure, I'm going to put out my nitrogen. Because remember, nitrogen has to be the central atom because it's the only one that can take more than one bond. You can't bond anything to hydrogen twice, because hydrogen only has a spot for 1 bond because it only has 1 electron, and so it can only have 2 total. So I'm going to attach my 3 hydrogens to the nitrogen. That's really the only way things can go. So when I do that, that uses up 2, 4, 6, because there are 2 electrons in a bond here and here as well. So 8 minus 6 is 2. And so you notice that the nitrogen isn't happy because it only has 6 valence electrons, has access to 6 valence electrons. So the last 2 are going to go up here. And that's really what we should see in a nitrogen, because when you do the Lewis structure for nitrogen, just by itself, I'm going to do it over here. You have the nitrogen, it goes 1, 2, 3, 4, 5. And so when you have the Lewis structure for nitrogen, there's those unshared pair that we put there. Okay, and then bond, 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 bond. That's how it gets to 8. Hydrogen only has 1 valence electron, and so we bond it, bond it, bond it. Okay? So that's a good Lewis structure, and if the question asks you for a Lewis structure, just go ahead. That's all you need. Now, the problem is with the Lewis structure is this is not how this looks in the real world. Okay? Things are not smashed flat. We don't live in 2 dimensions. We live in 3 dimensions. Okay? So I'm going to start to do a 3D drawing with my central atom. And since it has that unshared pair, I'm just going to put my unshared pair there. And as you get started, just check the chart, okay? But what I've got here is, and then I'm going to put in 1 hydrogen, okay? So this exists on the piece of paper, on the plane of the paper. This exists on the plane of the paper. But I have 2 more things to put in. And so when you look at it, it's going to be, get rid of that thumb there, it's going to be kind of like this, with the top of my hand having that unshared pair. So in order to indicate that, I'm going to put a triangle out. There's the other hydrogen, and then a dotted line back. And that's the other hydrogen. And so that's better indicates how that molecule looks. And so usually the angle between the hydrogens is 107 degrees. So the angle between here to here, and then really here to here is always going to be 107 degrees. In a perfect tetrahedron, it's 109 degrees. So what actually happens is that unshared pair kind of squeezes the shape down a little bit, because this kind of does this megamind field here, and it goes like that. So if you have 4 of the same thing, it flexes out to a normal tetrahedron at 109.5. If you have this, it flexes down to 107, and wait till you see when we do water. And we'll see what happens to the next one.